Hi, this is Emery. Thanks for taking the time to work on the Level 2 training for COPE. And what I'm doing right now is an introduction to course construction and just give you an overview of what's going on and give you some things that you need to know. The things you need to know are pay attention to the list of COPE elements that we do have. We have quite an extensive list of elements this year on the North Florida Council's course. Make sure the elements that you're planning to use are open. On the maintenance checklist, there'll be symbols up in there indicating if they're grayed out, don't use them. If they're not grayed out, then they're open. Okay. Usually, if we're working on a course, it should be very obvious. But if they're not on the list, even if they look like they're built, don't use them if they're closed. Okay. Make notes on things that you notice when you inspect the elements. If you see something like splinters, tree limb down on something, give us a note so that we can go ahead and take care of that. We're not trying to make you builders in the course. But you do need to know some things about how it's built and what tools are used and what we need you to communicate. So let's get started, and let's start with the staple of our course. And basically what you'll find almost everywhere in our course is 7 by 19 3/8 galvanized wire rope or aircraft cable, depending on how it's described. There's a lot of places in our course that this particular cable is not required, but you won't find anything on our course but this because it can be used in every one of the applications. So if you look at the end of the rope, wire rope out here, you can see that it's bundled around the little strands. There's all individual wires sitting like in there. You start counting, you'll get to 19, and then I'll show you where the 7 comes from here in the next slide. So when you start fraying these things apart, you'll find up in there that there's a center core basically running down the middle, and then wrapped around that center core are 6 different strands. So if you start counting, you got 1, 2, 3, 4, 5, 6 that are wrapped around the one in the center, and therefore you've got 7. So that's where our 7 comes from. 3/8 is the diameter of the wire rope. It needs some specialized tools to cut it. This is a Swiss-made wire rope cutter. It takes quite a bit of force, and you don't want to try to cut this in the air, although we have. But you can see there's a little picture there of a guy sitting on it. So I mean, it even takes a sitting technique. So you have to be able to cut the wire rope. Another way we're cutting the wire rope lately is we've really kind of enjoyed the angle grinder with the metal cutoff wheel. Makes it pretty easy, and you're not sitting there smashing and smashing on the cable trying to get it to cut. But sometimes we have a generator out in the middle of nowhere, your battery has died on your angle grinder, you just kind of have to suck it up and grab a cutter. Another thing you'll find on the course that's a specialized tool is a swaging tool. This thing is a 36 inch, which means the arms out there are 36 inches long. And you can see a swage there in the little round hole. And what's going to happen here is you take the swage, you put the swage in a little crimp. Of course, you've got cable running through there. You wouldn't just want to crimp the swage on its own. All right. And then when you compress it down, it's up in there and smashes it or crimps it, as it were. And as you'll notice, as these things get crimped, that they become longer. So you're actually stretching out this particular swage as it comes down. On every swage, you have to have a minimum of 3 crimps. That's what you're seeing here. Those are the marks that are left by the swaging tool. You can see that this one has 4. You have to have a minimum of 3 in order for it to take place. Now, swage with 3 crimps is the same thing as using 2 wire rope clips or 2 fist grips, which we'll talk about in a minute. Again, another angle on the little swage there you can see. Now, these are zinc plated copper. You don't have to have the zinc, you could be straight copper, but basically the zinc plated copper is what we use for the course. Here are fist grips. You can look at the fist grips. They clamp down on the cable. They got a nut on either side. We've been pretty much exclusively using fist grips because the fist grips came in at the same price as the wire rope clips, and these tend to leave us with a better feeling. We don't think they crush the cable quite as much. But if you take a look at this, you can see when it's turned on its side, the cable is running down through this, coming back up. Now I forgot to mention, let's go back for a second. See that thing out there that says dead end? That is the dead end of the cable. It doesn't really matter with a fist grip about the dead end of the cable. We're going to talk about wire rope clips here in a minute. So when we talk about wire rope clips, I don't want to leave out the fact that that's the dead end of the cable. So what we want to go on to now is let's talk about the wire rope clip. And with a wire rope clip, it's a little bit different. You have to have 2, but you can see the wire rope clip there has got a saddle there at the bottom. and the little bail or U or horseshoe or whatever you want to call it that goes over top of the cable, and then you see the dead end. Now, the phrase is, you never saddle a dead horse. So the wire rope clip there is properly positioned. The saddle is on the live end of the rope, or the wire that's going on around and coming back, and it's not on the dead end of the rope. And then we have a fist grip. Now this would be a legal connection. You don't have to have matched pairs. If you got a wire rope clip and a fist grip, you got two clamps that are legal for the using the cable, it would work. But you're going to find that most of the time you're either going to have wire rope clips or you're going to have fist grips. You're not going to have a combination of the two. Now these are all torqued down, and they're torqued down right now. We're doing it 45 pounds, and there's a range that's up in there, but 45 has been the magic number here lately. So you get your torque wrench out after you get it tightened down, and you start torquing them down to where they're 45 pounds of torque. Now next let's talk about bolts. This is a shoulder eye bolt. It's galvanized. The bolts are drop forged galvanized. Not something you'll go down to the hardware store and grab for the most part. Some of these bolts are 15, 20, 24 inches long on some of the ones we have on our course because of the size of our poles. And this one is a shouldered eye bolt, so if you look at the end of it there, you can see why it's called a shouldered eye bolt. It's got a round eye on the end, and then it's got an extra piece, the port there, which gives it a shoulder. Okay, but when you buy a bolt, you basically get what you see here. You get a nut on one end, and you get the bolt. Now here's a 45-degree thimble eye bolt, and the 45-degree thimble eye bolt is just what it sounds like it is. If you take a look at it, it's bent so that the load is designed to take in a 45-degree angle. So this comes through the pole, it goes down. So this is basically, you'll find this almost exclusively on our guide cables, but that's not the only place we use it. We use it for some backup places. But anytime that the cable is going down towards the ground or going down, and you can use these thimble eye bolts. Now let's take a little bit of a different view and a different angle on this thimble eye bolt. If you look through there, you'll see that there's a hole, and there's that nice little grooved or nice little smooth passage for the cable to wrap itself through, so that the cable itself is coming around, bending back at a nice smooth angle, and it's not wearing like it would be if it was shearing right straight back. And again, on the shouldered eye bolt, you take a look at it. With a shouldered eye bolt, one of its designs is the fact that you pretty much can load it in almost any direction because of that shoulder, and you're not really kind of too much worried. But we talk about oval eye bolt. Well, you got an oval eye bolt sitting up in there. This bolt, notice there's no shoulder, there's no bent up there, and it's got an angle. So basically what you want to do is keep the load or the cable or the stuff in the direction so it's in between those 45s. You don't want to have it and try to load it so it's going 90 degrees to the bolt or an opposite direction. You want to try to keep it in line with the load. And then straight thimble eye bolts are out there as well, and that's just as it is. They're designed so that they're giving the load in a straight direction off of the shaft, so it's coming through straight out the other end and straight to another attachment. Now there's more things besides thimble eye bolts. We do have wire rope thimble. Here's a 3/8 wire rope thimble shown here, and this is for using the cables, but bends around, comes through, and it goes. We're going to put this over a bolt in a minute. We'll discuss putting on a bolt in a minute, but we also have these on ropes. It's any place that you don't want to have excess wear. So if you had a carabiner through a rope, a lot of times you're going to find that we're going to have a thimble there, whether it's nylon or whether it's metal, depending on the application, so that you're not actually wearing right straight on the rope. And the thimble eye, the thimble itself kind of is like the thimble eye bolt. It makes a nice path for the cable to travel in, so you're not putting a lot of shear, a lot of extra force, a lot of wear on the thimble as it goes through. But primarily what you do is you take the thimble, you put the thimble eye through a bolt, and then you got an attachment point to the cable, so the cable is not rubbing and wearing directly on the bolt, it's wearing on the thimble. Now this is just a regular round eye bolt here. This is one that you would not want to load basically in a 90-degree angle to the shaft, so it's basically more of a straight out or similar to the load when you get to the oval eye bolt we had a few minutes ago. A lot of other stuff that we do use, we have a whole bunch of washers. We have a very cute one there, the helicoil lock washer. What that is basically a lock washer that's like a spring, so you can press that down against it. It's going to bound against one of these flat washers or curve washers we'll talk about in a minute. But the poles, as they dry out, is basically pressure treated lumber. If anybody building anything pressure treated lumber, as they tend to dry out, they tend to shrink. So when these are shrinking, the spring starts expanding and it keeps the nut locked to where it doesn't want to come off. And it gets inspected basically every 6 months. We inspect it, and then we have an outside vendor come and inspect the course. One of the things they do is tighten down the bolts. Now the flat square washer, use a lot of those around. The round washers are your typical washer we use, but we do use round washers. And then we have a couple other things for these curved washers. Now the curves, they more or less fit the form of the pole. So when you got a curved washer, the curve goes against the pole, then the helical comes down, the bolt comes up against the other side, and we'll make an assembly, which we'll look at here in a minute. The other thing out there we have as far as thimbles, we have these thimble eye nuts, and basically these nuts screw on the end of a bolt, and we have some pictures coming up later. We'll show you them in use. But these can be used if it on a guy. You don't use these on belays or any place you got a life or anything on. But if you got an inline non-moving load, like a guy at the top of an event, you can screw on one of these, and then the transfers the guy. But you wouldn't put this on something that you were actually going to put somebody's life on. This is a typical assembly, what it looks like. When you've got everything together, you got two curve washers. One goes on one side of the pole, one goes on the other side of the pole. There you see the little helical washer and the nut, and you tighten it down, boom, one bolt. We do use lag bolts in the course. There's several different places that we have lag bolts. Lag bolts, the diameter, the length, and everything is determined on the purpose for the lag bolt. For instance, the bolts that are up on the zip line platform for attaching participants to while we've got them in place, they're on there with lag bolts. We do a lot of platform building, which are also lag bolts, but the diameter and the length of the lag bolt is all determined on the job, the same as the bolt lengths and things are determined by the size of the pole, how much load they're going to carry, and what the purpose of it is. But we do use a lot of bolts. The big key here is everything you'll find is drop forged galvanized. You'll find very little rust on any of the stuff. It does, some of the stuff does rust, but for the most part, this bolt has been poured into a mold and formed and dipped and galvanized, so it's not going to go anywhere. This is a typical belay cable. You'll see on most of the courses you go around, and you see the belay cable sitting up in there. And we'll talk about it in a second here, because the belay cable is that extra cable that goes around and above the bolt there in the back. So the cable is actually attached to it. If you look at the front of it over here, you'll see that there's a swage, which we talked about earlier, that attaches the backup cable. Backup cable goes around the pole, and then there's two wire rope clips in front of that. Now, that's actually backing up the bolt. That's not backing up the cable. So when you see some stuff, and we'll show it a little while ago, that there are plenty of applications out there to where you don't have to have this assembly, but typically, not typically, if you have a bolt, you're going to have a backup on the bolt. You're going to have a minimum of two wire rope clips that are going to attach it back, because you have to get around the pole, and a swage. When the swage is with three crimps on it, is the same value as two wire rope clips, which is why there's not two swages sitting there in front of that. So if we go back up and look at this pole, starting at the top, you can see one of the wire, the thimble eye nuts up there at the top, where it's a guy, and it's when the guy is in line, there's the top one, and the next connection back here. It's a little trickier to see, but that cable is going down to the ground. That's 45 degree, and that's the nut and the bolt and the washer up there at the top of the pole. The next event cable down here, as we come down the event, is indeed an event cable. You don't see any backup, so that is something like the Multivine or Sky Steps. It wouldn't be a Sky Steps because that's heavy, but that's an event cable. There's no backup on the cable. Coming on down the pole, we continue to have belay cables here. If the PowerPoint will keep up with me, there we go. The next one down is a backed up cable, so that is the one that the traveler pulley is going to be on. That's the one the rope is going to be on for the participant. And this pole is a transition pole, so it's got one element going one direction, one going off at 90 degrees. So we come on down, that's the backup or the belay system for whatever event is coming off of the pole going 90 degrees. And then last but not least, we have another event cable down here at the bottom. Again, you can see it's a straight through thimble eye, swaged off, but there's no backup on it, so it's an event cable. So you're looking at this pole, you can see the same thing. We're going to take a closer look at the top of it, but you can kind of look at it now and you can see the difference between guide cables, event cables, and belay cables. Now let's go look at the top. At the top of this is what I was talking about, those inline screw-on thimbles. So it's a straight through thimble eye bolt going off to the right, and on the back side of that you've got the washer, the helicoil, the nut, then you got a nut and a thimble eye. Now this is called a buddy nut or a jam nut, but you put pressure on it, you screw it back together so that particular nut cannot screw off the end. So it is like a lock washer for all practical purposes. You're locking that screw-on thimble eye in place. Now this is a guide cable where it's a legal place to use a screw-on thimble eye. Other places, here's a 45-degree thimble eye. That cable coming down comes around our catwalk, and that is a backup on a heavy element. That log is very, very heavy, but that cable is backing up the bolt that you see there. So there's a bolt drive that goes all the way through the pole, all the way out the other side of the pole. It's got all the washers, it's got all the nuts on it, but then over and above that, it's got a galvanized cable wrapped around it. And you can't see the second swage, or even maybe third swage there, I think, but that cable is backing up that particular element. Now, also hanging off for our beam is our giant ladder. You can look here and you can see that we've got the bolt coming down. It's going to be a straight thimble line bolt, and it's holding the element up, and then in addition to that we have the backup cable that goes up, around, and down. Now we did this with all swages instead of with wire rope clips because people actually climb up for this and go up on the beam, and we didn't want to have all those nuts and stuff hanging there, so we did this all with swages. But again, remember that a swage with 3 crimps is the same as 2 wire rope clips. We're going to talk about these a little bit later, but these are also belay cables, and I'll show you what makes them belay cable, but you don't see the bolt there, so keep in mind that with the backups you see that wrapping around, you're backing up the bolt, you're not backing up the cable. Next up in here, let's take a look at our zipline guide cable. Our zipline guide cables that are coming to the ground. This is all 3/4 hardware on this pole. If you look, we're actually backing up the down guy. Again, because it's the amount of shock and force that's on this, so we're backing up the cable to the ground. So the zip line elements are typically have a backup that's coming down to the ground. If you look out here at those fist grips that we added up in there, there's 1, 2, 3 of them. And again, the reason there's 3, this is the heavy element, the zip line element, so it is something up in there that we're going to put a 3rd wire rope clip on. Policies in the past used to require 3, they're down to 2, but right now we're just doing 3, and then the backups have 2 on them. On the other side of our zip line, here we have a bolt that's going through here. This is our bolt where we attach the belay system for the people that are climbing the poles, or our participants are climbing up the pole, the zip line platform. This is the point in which you attach the shear reduction device and everything for that. Let's go in and look a little closer at this one. Look a little closer, you see you've got the bolt up in there, and then if you keep looking, that got a cable running through there. See, the cable goes around above the bolt. You see the wire rope clips on the side over there, the wire rope clips, and then it comes back around and the cable is going through the center of the bolt. So again, we're backing up the bolt, and when you're attaching the shear reduction device here with the carabiner or with the rapid link, whichever you're choosing to do with, what you want to make sure is you want to encapsulate both that cable and the bolt in your system, so that you're not just hanging somebody in a bolt. You don't want to just put up a person being belayed up a course in the bolt. Here's another angle on those other belay systems up in there, but you kind of get an idea. You can look up there, you can see the thimble eye, the down guy. This is off the end of the sky steps. Let's take a look at that other belay cable. So when you look at that belay cable, you'll see that there's a staple on one end of the pole, so the cable goes around, comes through that, so the cable can't get to the ground because it's resting on that galvanized staple that's through there. And if you look to the right, here's what makes it a belay cable. We got 1 swage with a minimum of 3. Again, most of our stuff is going to have 4. So you got 4 crimps on it, and then we have a second swage, and the second swage is what's backing up the connection. So you're backing up the swage, you're not backing up the cable. So when you got a cable like this that's up in the air, it goes around the pole, comes back, and it's got 2 crimps on it, it is something you can use a belay. If it's only got 1, then it's a foot cable on like our vertical playground. But This is a quick, easy way to make a belay cable. It's a little expensive because you're not running a lot of bolts. You don't have all those extra connections. It's a much cleaner looking application when you're doing it. If you're looking around at the guys that are coming down at the bottom, those anchors that get screwed in, when you start and you see 3 anchors down there, keep in mind 3 means heavy element typically to us. So when we got something that's important, very going to get a lot of shock, we use it's going to wind up with 3 wire rope clips and not with just 2. Something else is all over our course are step pole brackets. They're a bracket that gets over a little bolt there. There's a washer. These are removable. So we have number 10 cans that are full of these. Not full of these. They've got, I believe it's 7. There's 7 steps in each one of the cases. That gets us up 12 feet. Our elements are disabled at 12 feet. We don't carry ladders around. We have to do all that. So you can carry around a number 10 can. It has 7 of these brackets in it. And that way you can just go ahead and climb up there. You can hand and pull up on it, put the foot, and you can climb in the pole to 12 feet by using the step pole brackets. Here's shoulder eye bolt that's going through a pole, the confidence pole. This is one of the, basically it's a redirect on the belay system when you're using 2 ropes instead of just one, the adjust right descender. And you'll see the adjust right descender when we get to the course that's out there. Next, let's talk about the fact you can have more than one guy on the same anchor. These are utility anchors. They're a minimum of 3/4 inch. This particular one happens to be a 1 inch, 8 foot, has a 10-inch helicoil on the other end of it. This is not coming out of the ground. And you see the wire rope clips spread out there, and there's 3 of them. So this is 2 guide cables on our zip line. One's higher up the pole than the other, but they're coming down and attaching the same anchor because the anchor's got more strength. Typically what you're going to see in our guides are just simply 2. One of the reasons you'll basically only see wire rope clips at the bottom near the anchors is so we can adjust it. So when it gets time to tension the event, because the event eventually over time, people using it, they tend to get a little loose as it goes along. You can back these off, put what we call Haven grips, or some people call them pork chops, but they're basically a clamp that you can put on the cable that allows you to put a come along between them, crank and pull, and you can retension the guys, and we retension the guys, then we torque them back down to the 45 pounds, and we're set to go. There are foot cables in our course which are belay cables. There's a couple different reasons for them, but this is the 2-wire slack, which is at the lower end of the zip line, and you look down there and see the lowest cable is a belay cable. Well, this particular one is a belay cable because, and let's take a closer look here real quick so you guys get a good view of it. There it is. So you can see that it is backed up, cable goes back around, and this one is a belay cable because it's got something heavy hanging on it. The access to this at the other end is up a centipede, which is a bunch of 4x4s. Because of the extra weight that you're hanging on it before you put a body on it, we have got a belay cable as opposed to just a regular cable. We're taking a little extra care with it. There's other places on our course that have a belay cable. We do have Flying Squirrel, which is a foot cable for the Pirates Crossing, which doubles as the event cable for the Flying Squirrel. So that's a little bit about construction. We can talk about poles and things later, but basically what you need in a level 2 is you realize the poles are there, they've been inspected, they're the proper poles, the proper size, and again, the key here is the course has got an inspection which you have access to, and I will actually provide it for you in this course so you can take a look at it. And we also have a maintenance checklist. When you're going out to events, the maintenance checklist itself will say whether an event is open or whether an event is closed, and they heed that. So you're not going to get out there and don't need you to try to do repairs, go out and buy torque wrenches or wire rope cutters or angle grinders. But if you got interest in that, come join us. We do enjoy building on the course and doing it. We do have a very nice course. And thanks for your attention.